Hey YouTube, Matt here. Just wanted to give you a quick overview of my solar generator project here. What I got is a little ammo box I picked up at Harbor Freight and pretty much came up with a design I'm pretty happy with. It's got your standard accessories, and I'll get into more of that in a little bit, but why I ended up building one of these instead of buying was about a few years ago. We were experiencing a lot of power loss at our house, and I went on the internet like anybody else would and just started Googling around, looking up generators and seeing, what the different options were. And I happened to catch this one article about, about solar generators. So I was like, I've never heard of one of those. I'm thinking, what the heck is a solar generator? I knew, there's been a lot of advancements in solar, but haven't really been keeping up with the market. So came across a good article, intrigued me to do a lot of research, and I was pretty taken back by how much you could do with these things. So went on Amazon, started looking around different options, and I'm not gonna call anybody out, but quickly realized that these things are really expensive for the cost per capacity was really high. So I figured, like any typical guy or girl, that hey, I could probably build one of these myself. So started doing my homework there and came up and quickly realized that yeah, you could build one of these yourself. But before I started going down that path, I wanted to share a couple of things with you guys that I hopefully will save you some heartache, and some time and money, more importantly. The one thing I can't emphasize enough is do your homework. Do a lot of research and educate yourself. I bought several books. I'll share a lot of this information online. I have a blog. I've been keeping track of a lot of this progress. Read. You definitely make sure the sources that you're getting these information from is credible. Because what I found out in my research is there's a lot of bad information and a lot of dangerous misinformation out there. Some of the videos I'd watch on YouTube, I was waiting for stuff to blow up or catch on fire. I'm not joking. I'm sure if you've perused YouTube enough, you know there's a lot of crazy stuff out there. The other thing I learned is that a lot of things sound great in theory, but then when you actually build something like this and you or any project, right, you always realize, wow, in theory that should have worked and it didn't come out the way you quite expected it. So definitely do your testing, make us some investments, buy some stuff, kick some tires, and do whatever works for you. This is my first project, and I'm fairly happy with this, but I'm a stickler, so there's always improvements that I want to do, but I pretty much am at the point where I'm happy with what I've got here. And last thing, never stop improving until you're satisfied. I mean, this is my third, maybe fourth iteration of this. And I documented some of that. If you're interested, I'll put some links on there if you want to look at it. Bunch of different prototypes. So, but the formula for a solar generator is very straightforward. There's four components. You have your solar panel, which is your source of power, right? That's your charging source. You have a solar charge controller, which does three things. It maintains the voltage and amperage coming in from the solar panel. Then it also will manage what is going to your battery, right? So it looks at the state of charge of the battery, how much does it need, more or less power. It does a lot of things for you to not have to worry about. I've seen some guys just connect a panel directly up to the battery. In my opinion, that's just asking for problems, right? Nothing's telling that panel that, yeah, I've got enough charge, shut off. Unless you really just want to manually manage that process, by all means. But I'm like to configure things, plug them in, and not worry about it afterwards. The battery, no duh, right? So you want to be able to store the power that you're pulling in from the sun, and then your load. And the load is anything that's drawing the power. So in my case, I have a USB port and a 12-volt socket in this particular configuration. Any of these solar generators you'll see, and you see them, this one's a fairly small scale one. The same formula scales up, and I've seen some really cool concepts out there and products that the people sold that they've done. You know, trailer size solar generators, like massive trailers with lots of panels and a lot of standby power. Very, very cool stuff. Just poke around, you'll see them. Just actually, the quickest way I found a lot of those was just by looking at Google Images. Solar generators are a pretty safe word to type in on Google Images, so you should come up with a lot of relevant type results in that search. So what were my goals? My goals were to create something that was less than 120 watt use cases. So low power, you know, iPhones, Android, you know, whatever, smartphones, tablets, you know, batteries, lights, right? So I was trying to think of, okay, if I lose power, what do I want to make sure that I have? And I wanted to make sure that I could charge my phone, I could charge my kids' devices, you know, make sure we have enough lights. If my wife needed to charge her devices, you know, any of this stuff, I wanted to make sure that we had enough to get us by at least for a day, maybe two, depending on, you know, what's deemed critical and not critical. And you can, with this unit, you can hook up a low wattage inverter. You can definitely do that. I bought one to just do some testing on. But I think if I was going to do something where I was going to need a lot of AC power, I would build, I would definitely build a bigger unit. I wanted to be portable, right? I wanted to be able to pick this thing up and, you know, take it with me and definitely be modular, right? I wanted it to not be like, you know, I've seen a lot of good designs out there, nothing against those people that have made them, but I didn't want the panel to be, you know, part of the solution. I wanted to be something that I could, you know, detach and attach or, you know, make it more modular. I wanted to be rugged, right? And I'll explain to what a lot of these different you know, why you see these bolts in here. I wanted to make sure the battery wasn't going to move. I wanted to make sure the charge controller was rugged and it could take, you know, being moved around a lot and lifted up and dropped. And I wanted to be a very solid design. Safety, right? So I've got an inline fuse on this port, which I'll explain what that is in a minute. I've got a breaker here, 10 amp breaker on this switch, which is directly connected to the battery. So when you turn that on, it's turning the entire unit on and then turning the whole unit off. Wiring, and I'll show you the inside there. Used a couple different options and to make sure stuff was fairly solid, and, you know, not just electrical tape and prayer, hoping the thing was going to keep working. Water resistant, right? So all of these points of, you know, where I made a, you know, I drilled into this little plastic ammo box. I have seals on them and gaskets to make sure that, you know, this actual lid has got an O-ring on it that it could take getting wet, right? Not dropped in water, waterproof, but I wanted it to be, you know, hey, if you're outside, you're camping, you're tailgating, you're whatever you're doing, that, yeah, this thing can get wet and it wouldn't ruin the device. I also wanted to be non-proprietary. So if you've looked at a lot of solutions online, you'll notice that there are a lot of proprietary parts. Their lights only work with their units. Their panels only work with their units. I get why they do that, right? For, you know, safety, they've tested it, they've verified it, you know, helps them with their sales. But boy, when you look at the cost of some of that stuff, it's ridiculous. I wanted something that had greater than 100 amp hours of power. So this unit has a 12 volt, 12 amp hour battery. In theory, you get 144 watts, you know, which is, you know, plenty for charging a lot of the devices that I, you know, designed this specific unit for. And I wanted the total cost to be under 300. Initially, I wanted to do it for under 200. But the problem I was running into is that the components that I was getting were just too cheap, right? They worked and they did what they were supposed to do, but there was no way the thing was going to last, right? There was just quality issues. There were soldering problems I kept running into with some of these cheap components. You know, I figured, okay, look, I'm going to have to spend a little bit more to make this thing solid and meet my goals here. All right, let's talk about the solar charge controller. This is one area that I definitely did a lot of testing on. I had several different units. I'll open it up here so you can take a look. Pop this off. Take the lid off. This is really nice about these ammo boxes. And what you have here is the Star SunSaver 10 L. And what's significant about this controller and why I went with it is a couple of things. It had this cover, which makes it them be able to list it as UL listed. So it covers all the contacts, right? You don't just have everything sitting out. So again, what I didn't want to worry about was if I opened the unit and happened to drop something on there, it wasn't going to arc, you know, or short out anything. I wanted it to be able to give me more information, right? So battery level, this is very accurate. I've tested a lot that were, yeah, you got full charge out your middle, then you're completely discharged. So I found this to be a lot more accurate. I needed it to fit inside this case. That was the other challenge, right? A lot of controllers out there not ever designed to be put inside of something like this, right? They're tended to be wall mounted. If you can tell here, I cut a piece of oak, not real great, to get a free hand, but I wanted to be able to mount this to wood and make sure there was a little gap in between the wood and the back plate because there is a heat sink. I've yet to see this thing get really warm. I'm not driving it really hard. And then what I did is I zip tied this piece of wood to the bolts that are going in here. And then I shrink wrapped the bolts so they were insulated, right? So it wasn't just metal, you know, conducting onto the wood. I just wanted to make sure everything was really good and sealed up. So you don't have to worry about accidentally grounding the battery or whatever, right? I just kind of, that's how I like to do things. I'll just kind of over the top just to really make sure nothing was going to go bad or go wrong, because stuff happens, right? I'm sure a lot of you have experienced that. So what you'll initially see here is when you turn it on, it does a quick self-diagnosis and then, hey, battery state of charge is good. When you plug in the panel, this will light up and give you different statuses based on, you know, the input it's getting. I've plugged it, you know, tested it many times at the panel, and once this is all, everything is fully charged, this lights blink so you know you're good to go. I really went back and forth on, you know, getting a external battery meter, but for this design, I'm happy with it. All I have to do is lift the lid up, take a quick peek. What's my state of charge? Great. And then I'm good to go. These wire connectors I'll get into in a little bit and everything else in the accessories, but I'll touch on here in a few minutes. But just wanted to, again, this is the Star SunSaver 10L. The L, I believe, stands for the low voltage disconnect. The reason I got that is that I wanted it to make sure it would disconnect the load once the battery got down to a state of charge, you know, so you wouldn't impact the battery and damage it. So I didn't want to just completely drain the battery. I wanted to be able to make sure the controller would just disconnect it once it got down to that low voltage. The other thing I liked about this unit too is that it's completely sealed, right? This is, it can get damp. I'm not really worried about that, but it's sealed and it's very rugged, solid state design. It's not, man, there's a lot of cheap ones out there. You take the covers off and the soldering's bad. It just looks horrible. I wanted to make sure it was reputable. You know, Morningstar's a very reputable company, and I wanted to make sure that it could take, you know, being moved around a lot and take the jarring and, you know, all those concerns that I had about being portable. The battery, which, you know, nothing really sexy there, right? It's just a battery. But a couple things I wanted to note why I went with this particular battery configuration. It's 12 volt, 12 amp hour, like I mentioned before, but it is a sealed lead acid AGM battery, so absorbent glass mat. Why did I go that route? Well, I didn't want to worry about venting, right? I wanted it to be completely sealed, and the absorbent glass mat batteries tend to be able to take a little bit more of a beating than if it was a non-AGM battery. So do your homework on that. You make your own decision. This is what I chose to do. There's the, you know, negative and positive leads. They're going into here, going into the 10 amp circuit, and then, or I'm sorry, the breaker. The breaker goes in and then is wired in with the switch. So again, if you just shut that switch off, it kills power to the whole unit. Let's jump over to the load side. So on the load, I'll turn the unit back on. I had two things, and I've got some other ideas. I can maybe squeeze another one over on this side and maybe one up here, but it's getting pretty tight down in there, as you can see. I do have some elbow room, but again, I'm trying to make sure I just stop tinkering. You got to stop somewhere, right? This is just a marine grade. You've seen these all over the internet, eBay, Amazon. This is the USB marine grade dual USB 5-volt socket. One is 1 amp, the bottom one is 2.1 amps. So if you have tablets or smartphones that need more amperage, definitely plug it into the bottom one. The blue indicator shows that it is definitely receiving power. And then just your standard, 12 volt socket. Very straightforward. All right, well, let's talk about the accessories. What I have in here is a couple of things that I picked up for safety and again for ruggedness. So 10 amp breaker here, so thermal breaker, marine grade. These are the push wire connectors. What I didn't want to do, and again, the wiring is the way it is because I've tried different configurations, and I may or may not end up cleaning this up and getting the wire links right, but it works. Things are kind of a little stretched, not the way I wanted, but again, it's functional. But I definitely recommend you get these. I picked these up at Home Depot. You can get them online. Totally recommend these, right? Instead of, I personally don't like taking a bunch of wires and just twisting them together, putting them in a cap, and then putting electrical tape around them. I wanted to do the push wire. Creates like a little mini bus there, and allows you to connect all your positives together in one and have one lead come out. Very clean. Definitely would recommend them, and they're fairly inexpensive, so definitely worth the investment. Coming from the port, which I'll show you in a second, where you plug in for the solar panel, I have an inline fuse 10 amp measured, and make sure I match 10 amp everywhere, so I wouldn't exceed. This controller, by the way, I failed to mention that before. The 10 is a 10 amp max, so 12 volts at 10 amps, 120 watts, right? Coming in and going out on the load. Down here, this was something that a good friend of mine recommended. This is a Powerlet socket, right? So all I did was buy the socket. I want to actually, you can get them the same price on Powerlet, their website. You get the socket and the plug, and you take your solar panel, lift this up, plug it in. I just made the plug compatible with the wiring out to the solar panel. Forgot to bring that up to show you guys. Sorry about that. It's fairly straightforward. You can take that, plug it right in. And the reason I did it this way is in my original design, you had to lift the lid to plug in the solar panel. And I really didn't like that. It kept bugging me. And I thought, come on, there's gotta be a way to where you can plug in externally and never open this lid. Especially, I think about it, like if every time you open this lid and you're trying to use this as as the generator's intended to, you risk something falling in here, it getting wet, so on and so forth. So in my opinion, the less this thing open, the better. So good friend of mine recommended this. I never heard of it. I guess it's pretty popular with motorcycles, and I wish I had a bike, but I don't. So yeah, he's like, yeah, definitely pick those up, look into them, and you can do, I think it's 15 amps is the max you can do at 12 volts. So well within my spec of 10 amps. The other thing I wanted to show you here on this side, on-off switch, millions and millions of these that you can find online. Have that in line with the breaker. So there's a little boot that goes with this. I gotta find somebody that carries it on Amazon. It looked like it was supposed to come with it. It was in the picture, but it's not. So there's some other ones I'm looking at if I can't find the boot for this to keep this covered. So in case to prevent water from going in there. But as I said before, I added these gaskets around here. I reinforced, I'll try to get this in so you can see that here. I got these bushings to reinforce the plastic, because when I just did the, this straight up, it was kind of flimsy. I wasn't happy with it, so asked around. There's a great local hardware store here. Took it in, showed the guys what I was doing. They're like, "Oh yeah, we've got bushings that'll fit this," and got those in there and firm these up. They don't even move at all. It just gives it more backing. The other thing I'm going to do is, you see all these exposed contacts. I bought some of that liquid electrical tape, but I didn't want to put it on obviously until this was the final product. So I plan on doing that. These bolts, right? So if you I saw a lot of solutions out there, guys using Velcro. So I actually have a industrialized, the Velcro, right? I had the brand Velcro. I have it on the bottom, holding the battery down there, but there was no way it was just going to keep that battery from falling or moving around if this thing got jarred around a lot. So I do have it in there. It does help it from moving a little bit, but this is why I have this pattern on here, and just did some measuring. If you're interested, I can share those measurements. I did document that in case I wanted to make another unit, so that the battery would fit in there, and nothing moves, right? This thing isn't, the battery is just very, very secure in there. Really happy with that. So what's next, right? So I've been thinking a lot of different things I could do, make bigger units. I've had some people ask me if I would build them for them. Been kicking around a lot of different things. I do have a full-time job. This is just something I do as a hobby. But what I decided to do, couple things. I am willing to build these for people if they're interested. There's no shortage of commercial ones out there. I've seen a lot of good designs online. Guys make these for under $100 with spare parts, and I've seen them go into the thousands of dollars with some really scary designs that literally they take a toolbox, a battery, a really cheap charge or inverter, and slap the thing on and say it's a product. My goal was to just again keep it reasonable, something that I was comfortable doing. I learned a ton doing this, but one thing I definitely want to try, and I did buy, I've been looking at a couple of controllers to pair up the battery, is lithium iron phosphate batteries. They are incredible. A lot of different types of lithium batteries out there, but the lithium iron phosphate batteries are very, very prevalent. I'm hearing them, coming out with more inside of more and more products, right? Why? Well, they're not toxic, very stable batteries. They can be cycled, meaning they can be taken, full state of charge to, to where they're past the point of, I think that they get down to like 10 or 9 volts is some of the stuff I've read, but they can be cycled, 3 times as much as this battery before it goes bad. It loses very, very little charge, when it's sitting and being shelved, meaning it's not receiving any type of charge, trickle or from solar. And it's really, really light. It would lighten this up. I believe this battery, I'm going by memory, I think it's like 9 or 10 pounds for a 12 amp hour battery. But hey, it's full of lead, so no shocker there. But that lithium battery is 3. So, but the drawback is with lithium iron phosphate is it's 3 times as much, right? So this battery, I think it was like 25 bucks. That lithium iron phosphate battery, actually it's more than 3 times. I think the battery's like 120 some dollars. So yeah, you're looking at like 5x the cost, but you get 3 times the life, and it's a lot lighter. The main rub is you can't use those controllers, right? There's millions and millions of these charge controllers that support lead acid batteries. They, do different stages of charging, versus, bulk charge, floats, and there's 4 different methods out there. But with lithium batteries, it's completely different ball game, right? It's constant current and constant voltage. So that's all they really care about. The batteries are different. They have battery management systems. Some of them have them built on, some of them don't. It's just different, right? You change the battery, you got to make sure you pair up the right controller. So that's my next goal, is to kind of make this maybe with that same battery, a bigger battery, a little bit bigger case. But again, I'm just trying to keep it, you know, reasonable and portable is the goal. The other thing I would recommend you pick up, let me scoot this back a little bit, is one of these guys. This is a, I don't even know how to pronounce this, Droke USB tester. There's a lot of them. I really like this one. I have a couple other ones that they work okay. But what's nice about this, you turn on, I'll turn on the unit here, plug it in, and, oops, I already had it on, so let me turn it back on. You plug it in, right, and it immediately gives you, not sure how that's, yeah, it looks like it's coming out pretty good in the camera. It's 5 volts to 0 amps, so if you plug something in, and I happen to have my little USB fan, plug this guy in. Let me make sure, yeah, so turn this guy on, and that's on low. You can see, okay, well, how many volts and how many amps is it drawing? Well, who cares, right? Well, the reason you want to care is that the question I get every single time when I show somebody this thing is, oh, well, what can it charge? Or how many times can I recharge my phone? Or what can you power off of that? Can it do this? Can it do that? The only way you know is that you have to measure, right? You're gonna have to measure how long, you know, well, at low power, this is how much this unit draws. Let me turn the fan up. You'll see it's consuming, you know, 5 volts, 5.09 volts at 0.41 amps. And then you can find out, oh, multiply to 2. Okay, well, that's how many watts per hour it would use. As I hit my fan, my hand on the fan. That's how you would calculate your capacity, right? So if I ran the fan at full power for an hour, I would use that many watts. So then you just divide it into how many watts your battery is, and then you know, okay, I can run the fan for X amount of hours before it would drain down and cut off. So if you're going to convert from DC to AC power using an inverter, right? There's millions of them online. Definitely make the investment in a pure sine wave inverter. Well, why? You'll find the vast majority of inverters out there are modified, or there's a lot of different terminology out of it, but if it doesn't say pure sine wave inverter, I personally would stay away from them. If you get a pure sine wave, you gain 2 things. You never have to worry about what you plug into the thing. And second, it will utilize the battery draw more efficiently than a modified. Go ahead and do your homework on that. It's definitely worth they're getting cheaper and cheaper. There's a lot of good brands out there. You know, definitely take a look around on Amazon and do your homework on it. I've looked and bought a couple of them. Happy with some, not happy with others. But just stay away from the cheapy ones. They'll draw down your battery quicker, and depending on what you plug into it, it can cause damage or make it run more inefficient. Especially, I've seen a lot of demo videos of a fan, right? Just doing a modified inverter off of a fan. You do a difference between that and then a pure sine wave. It runs quieter, runs cooler. Again, if you're trying to get as much much battery capacity out of this, make that investment. There's a lot of good ones out there, but there's a lot of junk ones out there. So definitely do your homework on that. So, okay, if you like the video, please subscribe below. If you have any recommendations, any feedback, add some comments. I'm open-minded. I wanted to share this with everybody. You want to build your own. I'm trying to document as much as I can. If you're interested in me building one, you know, let me know. You know, private message me. We can work out something. What my goal is, what I'm really kicking around the idea is it's not that I want to make the money. I just really enjoy doing this kind of stuff. So my idea is that what I would ask you to do is pay for the parts. I'll build it labor free. I just would ask you to make a donation to your charity of choice and just kind of show me evidence that you did it, and we'll work out the details there. So just want to make sure that my time is valuable, but make sure it goes towards a worthy cause. Okay, that's it. I hope this was helpful. Hope you guys enjoyed the design. Really happy with it. And if you have any questions, let me know. Thanks.